Hi, welcome back. This is Professor Ridge, and today's lesson on section R.3, addition, subtraction, and multiplication of polynomials. A polynomial in one variable is any expression of type a sub n x to the n plus a sub n minus 1 to the x n minus 1 plus dot 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 a sub 2 x squared plus a sub 1 x plus a sub 0. So this is just a fancy way of these a sub characteristics. The sub n has no numerical value. It's just distinguishing, hey, that's the coefficient for the nth degree term, right? And so a sub 2 is the coefficient for the x squared term, for the quadratic term, right? So that's the subscripts for, so you can distinguish which coefficient we're talking about. So it's just notation, no big deal. And where n is a non-negative integer, okay, that's key. So you can't have x to the negative 5, that wouldn't be a polynomial, right? So it has to be x to the first, x squared, x cubed, so on. And then the coefficients, a sub n to a sub 0, they have to be real numbers. Okay? The parts separated by plus signs are called terms. So again, if we had like 5x squared minus 2x, you would think of that as plus a negative 2x, so that would separate it. So we always want to think plus signs. Okay, the leading coefficient is a sub n, so that's with the highest degree term. And then we call the term that has no variable, a sub 0, we call that the constant term, because it's not going to vary. Right? It's the constant term. So provided that first term is not 0, then the degree of the polynomial is going to be the n. So it's the highest degree term is going to be the degree of the polynomial. And if we have it written the way from the highest degree to lowest degree, x to the n, x to the n minus 1 down to the constant term, we call that descending order. Now we're going to be careful when we have polynomials in several variables. This is for one variable. The degree is a little bit different. So in polynomials in several variables, the degree of a term is the sum of the exponents of the variables of that term only, right? So we're just talking about a single term. Add it only for emphasis, right? It's just that term only. Now the degree of the polynomial then is still the same. It's the highest degree term. So you figure out what the degree is each term by adding up the exponents for all the variables for each individual term, and then you take the highest degree term, and that's the degree of the polynomial. Okay, let's look at an example list for each term of the polynomial. I want you to identify the term, coefficient, degree of the term, and then the degree of the polynomial. Okay, so this has 1, 2, 3, 4, 5 terms. So the first term is 6x cubed y. Coefficient is just the number 6. And the degree is the 3 plus 1, which is 4. The next term is 7xy to the fifth. 7 is the coefficient. The degree is 1 plus 5, which is 6. The next term is negative 3x. So negative 3 is the coefficient. The degree is just 1. Next term is 4x 4y cubed. Coefficient is 4. The degree is 4 plus 3, which is 7. And then the last term is negative 7. Coefficient is negative 7. The degree is 0. So the degree of the polynomial is the highest one, which is the 7. Okay? So that's the 7th degree polynomial. So to add polynomials, just combine like terms. I'm not going to do any example of those. I'm sure you're comfortable with that. And again, if not, just ask me in class. just combine like terms. To subtract, you're going to distribute the minus sign for the second one, and then, or I'm just going to say this, we're just going to add the opposite. So we're going to change the signs of all the terms in the second polynomial and then combine like terms. Okay, so I'll do an example of that one, next page. So again, well, we're just going to subtract, means we're going to add the opposite. We're going to take that minus sign and we're going to distribute it to each term. So we're going to leave the first one alone. Then it becomes plus a negative 4x, but I'm just going to write minus 4x squared, minus 3x, minus a minus 8 becomes plus 8. Now I'm going to combine my like terms. So again, just get in the habit of doing descending order. So I'm going to put all my x, I look for the highest degree, which is x cubed. Write that down first. There's no other x cubes, you just write it down. X squares, I got 3x squared, negative 3x squared, and negative 4x squared. So that's negative 7x squared. And then I have 2x and negative 3x, so that's negative 1x, or just negative x. And then I have the 5 and the positive 8, the constants, so plus 13. So if you get in the habit of doing descending order, you're not going to miss anything, and you're less likely to make mistakes. Okay? Wrote A, I'm not going to do a B, so hopefully it's pretty straightforward. Now multiplying, how do we multiply these things? Well, we start off with multiplying monomials. So if I did 5x cubed y times 3xy squared, well, it's no different than if we're using exponent rules, and it's just times signs. So it's, again, I'm going to do the numbers, the coefficients. 5 times 3 is 15. Do the x's, x cubed times x to the first, so that's x to the fourth, and then y times y squared is y cubed. Okay, so nothing new there. If I do a monomial with a binomial, we're going to distribute. You're going to take this 5x squared and distribute it. So you're going to get 15x cubed plus 20x squared. And then of course if you do a binomial with a binomial, we're going to FOIL. And I kind of like to stay away from saying the word FOIL. I mean, it's kind of ingrained in me too, but we're really distributing. All these are distributing. So you take the first term and distribute it. So we get 12x squared. Take the first term, distribute the second term in the second parenthesis. So 3x times 5y is 15xy. Okay, so now the first term's been distributed. Then you go to the second term, and we're going to distribute it to both terms. So that's going to be 16xy plus 20y squared. And then we look to combine like terms. 31xy. And then that's it. So again, you should be pretty comfortable with multiplying polynomials. And then the special products. Now these, college algebra, I really want you to get these memorized, so I want you to practice these. And you'll see later on I'm going to be just, expecting you know how to do it. Special products of binomials. Okay, so the special products that you should memorize these. These are shortcuts because they're things that we do a lot. We do a lot of squaring. So if you take binomial and square it, and yeah, if you forget, you just use the, you just FOIL it, and then you get this. So it's going to be a squared plus 2ab plus b squared. I don't really necessarily remember memorize the second one. To me, these two are the same thing. The only difference is if that's minus in the middle, you get minus 2ab. So for me, the way I kind of memorize stuff, to me that those are exactly the same problem. No difference. Because I don't think a minus b, I think a plus a negative number. And so if I go 2 times a times negative b, I'm going to get negative 2ab. Alright? So anyway. And then the last one is if you take the product of a sum and a difference, we're going to get difference of two squares. So a squared minus b squared. These are big ideas that we want to memorize these. So if I do, like, say 3x plus 5 squared, I can square the 3x on the fly, kind of 2 times 3x times 5 plus 5 squared. And I wouldn't write that down, I just write the answer as I go. So 3x squared, 3x times 3x is 9x squared. And I do the numbers, 2 times 3 times 5, and you do it whatever order you want. 3 times 5 is 15, times 2 is 30. Or I can go 2 times 3 is 6, times 5 is 30. Or I can go 2 times 5 is 10, times 3 is 30. And then attach the letters. So, you know, typically what I do is I go 3 times 5 is 15, then double it because of from the formula 2. That gets me 30. And then 5 squared is 25. So I want you to be able to do it that quickly. So if I had, say, 7x minus 2 squared, I'm going to do 7x times 7x is 49x squared. I'm going to do the 2 times the 7x times 2, but, you know, I kind of ignore the x for a moment. I go 2 times 7 is 14, times 2 is 28. That's minus. And then I attach the x. And then I take the last thing, negative 2 times negative 2 is 4. And that's it. So if I had 3x, or yeah, 3x minus 8y, I'm going to go 9x squared, 3x times 3x. Then I'm going to, again, I do the numbers. 3 times 8 is 24, double it. Or I go 2 times 3 is 6, times 8 is 48. It'll be negative 48 because of the minus sign. And then attach the letters, x, y, because you're multiplying them all together. And then 8 times 8 is 64, y squared. Okay? So you should be able to do it that quickly. And of course, difference of squares one, you know, that should be no problem. So what you have to recognize are the same numbers, one's plus, one's minus. So you square the first term, 16x squared, minus square the second term, 25. You're done. Okay, so those are really important. We see them a lot. Memorize them, practice them, and I want you to be able to do those. Okay. So that concludes the review for section 3, and go to My Math Lab, complete your exercise there, and I'll see you in class.